Hello everyone. Before we start into Azure container instance, let us see what is Docker and how we can use Docker to run containers to solve the challenges in any IT infrastructure. For application development, we know that the application can be very small, starting from very basic application like the calculator application, which is available in the operating system itself. And there are some applications which are used by the enterprise like MS Office, MS Exchange, SharePoint application, any ERP application, any CRM application, Apache Web Server, Tomcat application. So there are many applications like this which we are going to deploy in our infrastructure. These applications can be categorized from small to medium to enterprise application. So we can categorize the application from small to medium to enterprise application. So this is the range of application what we are going to use in our infrastructure. And there are also other type of application which are heavyweight application which are used in medical, banking, stock exchange, which requires more hardware power, which is CPU, memory and disk. In order to deploy all these application, we require the physical hardware. So this is the physical hardware on which we are deploying the application. So there is the operating system layer and they have the application layer. So we have the application which we are going to deploy on the physical server, and we have been able to move this physical environment using the virtual environment. So we are able to abstract the physical layer using the virtual machines. Now we have the hardware and we have the hypervisor. So using the help of abstracting the hardware layer, we are able to deploy our application on the virtual machine. So this is the application which we are able to deploy. This is the application number 1. This is the application number 2, which we are deploying on the same hardware platform. Here we used to run one server is to one application, and here we are capable of having or running multiple applications on the same server with the help of hardware abstraction. To write the code and to manage the hosting infrastructure, we had multiple teams. So we had multiple teams involved. We had the developer team and we had the infra team or the operation team who is going to manage all these hosting services, and developer team will write the code for the application. In order to deploy the application on the hosting infrastructure, we will first test the application on the testing environment, and we use development environment, then QA and pre-prod. Then at last we will deploy the application on the prod. So there are multiple levels of deploying the application which we are going to test. So the kind of environment whatever we are using for deploying our application on multiple environments, it will not be same. For the test environment, we might be using less CPU power, less memory and less storage. So from testing to production, the environment might change. So there is no consistent hosting infrastructure what is going to be provided. There are several challenges managing the current way of deploying the application. Let us see these challenges one by one. Managing the hosting environment, which requires both the installed software and the configured hardware in each of the environment is same. Whenever we deploy the application onto the test environment, onto the development environment, or pre-prod or prod environment, we need to have the consistency of the software and the hardware. We also need to configure network, data storage, security for each of the environment. So we need to configure network access, storage access for each of these environment. So this is the network access, this is the storage access and security per environment in a consistent and easily reproducible manner. The second challenge is continuity in software delivery. The system package must include the binaries, the libraries, and the configuration files, and all other dependencies to see to that it matches the software version and the architecture. The third challenge is efficient use of hardware. We need to ensure that the application is isolated from other applications which are running on the same hardware. As I told, many times we limit one operating system to one application or one physical server to one application, one virtual machine to one application. Just to avoid the conflict of the application with another application running on the same hardware, what we will do is we will run the application on one virtual machine or one physical server just to avoid the crash of the application or impact of the application if we are going to run with multiple applications on the same hosting infrastructure. The fourth challenge is application portability. If the hosting environment fails, if we have deployed the application and we have deployed this application onto this hosting infrastructure, if this fails, are we able to scale this application to another server or to another virtual machine? Are we able to move this application to another server or virtual machine? Or if we are able to scale the application, and in some cases, we might have the virtual machine which is running different versions of operating system. So the current application which is running on Red Hat 6, we wanted to move this application to Red Hat 7 and Red Hat 8. So we have the code which is written for this application for Red Hat 6.0. Are we able to run the same application on Red Hat 7 or Red Hat 8.0? So these kind of move from one hosting infrastructure to another hosting infrastructure should be fast as possible, and this is to reduce the downtime. So these are some of the challenges out of many challenges which we will solve using the container. So what is container? A container is an operating system virtualization method which allows us to build and run software packages. So these software packages the software packages for the container to run, it requires the application code itself and the binaries, the libraries, config file, and any other dependencies. So all these are all included in the software package, and this is the package which we will use to run the container. So this software package is called as container image. So the container image will be having the application code, binaries, libraries, config files, and dependencies. So these are just files which are required to run the containers. And using the same software package, which is called as container image. So this is the image. We will be able to run multiple containers, hundreds and thousands of containers we will be able to run from the same image. So it can be one container to thousands of containers. Software containerization is a method which allows multiple containers to be deployed and run on the same operating system, which can be Linux operating system or Windows operating system, without using the virtual machine for each of the container. So basically we don't require each. So for every container, we don't require one virtual machine. We can deploy multiples of containers on the same virtual machine. Either it can be on the same virtual machine or it can be on the physical server. So we can run containers on multiple platforms. We can run on Linux and we can also run on Windows operating system. We now know there is a method called as software virtualization, which allows multiple instances of containers to be run on the same operating system. So there are multiple instances of the container which can be run on the same operating system. So what is the technology or platform to take advantage of operating system virtualization? So this is operating system virtualization, on which we are able to deploy multiple containers. So what is the technology which allows us to run multiple containers on the same operating system? This technology or platform is called as Docker. This is a software program which allows to run multiple containers on the same operating system. For demo version or demo lab, we will be able to use the desktop version of the Docker, which is available for free to download. We will be able to install the desktop version of the Docker on Linux, Windows, and Mac operating system. For production environment, basically we run the containers mainly on Linux environment, and we can also run the containers on Microsoft Windows servers, which are 2016 and above version, and we will be able to deploy the Docker on different cloud service platform, including Azure. When we install the Docker, we get three main components. So when we download and install the Docker on our host, we get three main components. So these three components are server component, the REST API component, and the client. These components put together is called as Docker engine. The Docker server runs a process which is called as Docker daemon. So Docker server is just a service which is run as Docker daemon in the host operating system. There is a Docker client which we use to send our commands. So we use the CLI to send the commands to the Docker client. Then these commands will be sent to the REST API as the API calls to the Docker server. Then the commands will be executed at the Docker server layer. These commands can be Docker run command, Docker build command, Docker start, stop, Docker push command, Docker pull commands. And the images, whatever we are seeing here, this is the images which are there in our local host. These images are called as local cached images because it is there in our local host. If I wanted to pull any new images, we need to go to Docker Hub. So this is the repository where we will be able to pull the images from Docker Hub. We will be able to pull, there are many public images which are available. If I wanted to pull any of the images like MySQL, there is an image in the Docker Hub. We will be able to use the Docker pull command to pull the image, and we will be able to store the MySQL image in the local cache. Once I have the image, then I will be able to build the containers using these images. It is not that I am able to build only one containers. Using the same image, I will be able to build multiple containers. So if I have pulled Ubuntu Linux and this is the image, I will be able to deploy multiple containers out of the same image. And even for the Windows image, I'll be able to deploy multiple containers like this. And even for Nginx, I'll be able to deploy multiple containers. If I wanted to deploy new containers, then I'll be able to pull the image from the Docker Hub, which is the repository. So this is the repo from where I'll be able to pull the images and deploy the containers. You might be asking a question. If I am running multiple containers out of the same image, will I be able to delete the image? No. Whenever you are running containers out of the same image, even if one of the container is running, you will not be able to delete the image. Let us see what is Docker client. There are two ways how we interact with the Docker client. One is via the GUI and the other one is via the CLI. If I install the Docker desktop, which is basically used for demo purpose or lab purpose, if I wanted to run some demo images, demo containers, I'll be able to install the Docker desktop and use the GUI interface. So this is for Docker desktop. And if I am in production environment, I'll be using the CLI interface to send all the commands to the Docker client. The commands, whatever I have sent, it will be sent as an API calls, and API calls, it will be sent to the Docker server. So this server is going to execute the commands, whatever we have sent. It can be Docker run, stop, etc. Docker server is a daemon which is called as dockerd. This is a process which runs on the host operating system, and this daemon or process responds to the request from the client via the Docker REST API. It can also interact with other daemons or processes or services. The Docker server is also responsible for tracking the lifecycle of the containers. Running Docker container is not the only requirement for the application which we are going to deploy. So we have the application. Running the application on the container is not the only requirement. We might be having the requirement of accessing the storage volumes, or we might be accessing the Azure file shares or Azure blobs. And we also might have requirement to access the network, to connect to the external network via the host network. Additionally, we might have other plugins as well to manage, monitor the containers. Docker Hub is a central repository from where we are pulling the images to deploy our containers. Docker Hub can be divided into public and private registry. All the public images like Nginx, Ubuntu, MySQL, or very basic container images such as Hello World, Alpine. So these are the very basic images which we will get from the public repository. Private repository is for the enterprise, where they will store all their customized images which will be used for their business. And using these private images, they will be deploying their containers to run the business application. These private images will not be shared to the public users. So this was the introduction to the Docker. If you like the content, please subscribe and share the video. Thank you and take care.